Now we are on question number 9. It says the angle of elevation of the top of a building from the foot of a tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50-meter high, we have to find the height of the building. So what we need to do is to make two structures, right? In questions like this, let's make two structures, ignoring which is the building or which is the tower here. Like I made the base, then I made a big structure, and then a smaller one, right? Ignoring as of now, which is building and which is the tower. Let's name it. This is A, B, C, D. Now, when you read the question, it says that the angle of elevations made from the base of one to the top of the other, and similarly, the angle of elevations made from the, again, the bottom of one structure to the top of the other. From the figure, you can very well able to identify the bigger angle is this. So mark it 60 degree. And the smaller angle, again, this is 30 degree. Now, read the question again. Which, in order to find which is building and which is the tower, it says that the first one, it says that the elevation of the top of the building from the foot of the tower is 30 degree. Top of the building is this, right? And the foot of the tower is this. Therefore, because this angle is given as 30 degree. So it's very important to understand. Most of you write opposite or randomly anything which is wrong. So need to understand the elevation of the top of the building. So therefore, AB is the building. So once we identify that, this is the building. This is the building. Now we can see the dimensions given here. As you can see, the dimension or the length of the tower is mentioned. Once we identified that AB is the building, therefore by default DC is the tower, and it is mentioned it is 50 meter tall. So let's write this as 50 meter. That is the only problem where most of you get stuck. I mean, identifying which one is building and which one is the tower. Now we have to find the height of the building. So this is the question mark. So what we need to do here is, that's very simple. We will apply tan 60 in one of these triangle, and which one has to be this one, right? We are talking about this right angle triangle. In this right angle triangle, first we'll obtain the BC as we know the length of the perpendicular. So applying tan, let's first mention the triangle. So we are talking about in triangle A, sorry, it's BCD, in triangle BCD. Tan 60, as you know, tan is perpendicular upon base, so it is DC upon BC. Tan 60, whose value is √3, is equal to DC, which is mentioned as 50 over BC. And by cross multiplication, we get BC is equal to 50 over √3. It's not necessary to rationalize it at this stage, as we are not looking for the final. This is not the final answer. Now we will consider the another right angle triangle, and this time we'll be taking the triangle. This time we'll take triangle ABC. So in triangle ABC, we can use tan 30, which is perpendicular. This time AB is the perpendicular and BC is the base. The value of tan 30 is 1 over √3. AB, which we are required to find out, and the BC, which we have already calculated. The length of BC is this, right? So we may write this as, you know, that dividing by 50 over √3. Now, if you do cross multiplication, we'll get something like this. √3 times AB is equal to 50 over √3. And when you transpose √3 on the other side, it will be multiplied. Now, then we need to find out the final answer. √3 into √3 is 3. And if you reduce it, you'll get 16.666, which we write as 16.67. or you may leave in the fraction also 16 2/3. That's in meter. Any of them, right? That's the final answer for this question.